Today, we'll look at a fun one. Does it matter to have more genes versus one gene when it comes to a strong resistance against WRF? It sounds intuitive, right? More genes is better. But is this true for tomato breeding, and is this true for resistance against WRF? Sergio, you are considered within ENSA as the expert on WRF. I would even say outside of ENSA, you're the WRF expert. Can you say a little bit about how we generally treat single dominant genes versus recessive genes when it comes to finding a solution for a disease in the market?
Traditionally, already for more than 100 years of breeding in tomato genetics, we mainly have been focused on single-based resistances. So a majority of that, vast majority, is dominant. So if you look at a package of tomato and look at the resistances on that are high resistances, they're all based on single genes.
Can you say, at least from ENSA perspective, what does high resistance means in the case of HREZ?
Yeah, there's a clear example of high resistance against the same type of virus as the viruses, namely tomato mosaic virus, TOMV. And that is based on the TM22 gene. It's a single dominant resistant gene that looks very much like the HREZ gene. It works the same, it has the same pitfalls, it has the same strengths. And this is a high resistance that has been regarded in the tomato industry for over 50 years as a true high resistance. So in tomato breeding, we have been making use of single-based resistances like the TM22, a dominant R gene working for over 50 years. And the HREZ gene is no different from that.
HREZ, our solution against WRF, is a single dominant gene. That means that only one of the parents needs to have this gene in order for their offspring to be completely resistant. To get a better understanding, let's pay Nella a visit, our expert in molecular marker development. We were just there in the greenhouse with Sergio, and he was very big fan about single dominant genes. Can you say a little bit about what a single dominant gene is and how it differs from a recessive gene?
A single dominant gene is something that we always hope to find when we start a mapping project or trying to find resistance. And what it basically means is if you have even a single copy of this gene, so for example in tomato usually you have 2 copies of a gene. So if you have a single copy, you will have your phenotype, so your resistance. While when you have recessive, you need to have both copies of the recessive gene in order to have the resistance. Having a single dominant gene really brings clarity and speed through the whole breeding process. Thank God. You can do that.
So this is the first step. Is this already breaking? So, the takeaway. Single dominant genes mean speed. Speed in breeding. Speed in breeding means adaptability. The virus will always evolve, but with speed in breeding we can quickly adapt to new situations. The future strategy of ENSA, we might want to stack other mechanisms, other resources to our HREZ. Can you say a little bit about what makes HREZ such a unique and important cornerstone of that stacking approach?
Yeah, so HREZ is kind of foundation of the, let's say, of the whole building you need to make in order to get a thorough wall against the virus. And this foundation is based on the fact that the virus is recognized and killed. Other mechanisms, so far we know, do not have this specific mechanism. They work through other ways. Actually, they limit, for example, the virus from entering the cell, or they take care that the virus is impeded in multiplying throughout the cell. but HREZ is the only way to actively get rid of the virus. By using these additional, let's say, layers of defense is a way to keeping the virus pressure low in order to prevent that the HREZ mechanism will be broken. Maybe as a comparison, we could look into how we used mouth masks against COVID.
Mm-hmm.
These mouth masks were not preventing us from getting COVID. The mouth masks were preventing us in spreading the virus. If you want to prevent COVID, you need to have a vaccine to boost your immune system. And it's your immune system that kills the virus. HREZ works through a very strong and specific recognition mechanism. It's the only way to actively kill the virus when it's in the plant. Other mechanisms work in other ways, but the HREZ is a foundation. With these other mechanisms, you build upon a strong foundation.
More genes isn't necessarily better. A single gene isn't necessarily better. It all depends on the resistance mechanism, how strong the foundation of that resistance mechanism is. With HREZ, we have a very strong resistance mechanism. And maybe in the future, we can find complementary methods of resistance to stack on that. But the basis is always HREZ. And with this, we can provide long enduring resistance to you, our growers.